Hey everyone, I'm on a mission to see if I can create an entire game and ship it using nothing but AI tools. So if you've been seeing some of my previous videos, most of the time I've been using asset packs that I get off itch.io. The biggest question I always get is, how do I use AI to generate my own custom assets? Today, I'll be showing you how every single art asset that you see over here, I can walk, I can run, I can jump, and I can also have an attack animation and a death animation as well. Every single art asset was AI generated from scratch. In today's video, I'll be showing you my exact workflow to create all of these art assets animated completely using AI. This uses a combination of GPT Image 1.5. And for more complicated animations, I made use of the Sora 2 video generation model. And as you can see here, the results are quite impressive. You can create these art assets for your games without leaving your favorite AI tool, whether it's Claude Code, Codex CLI, Codex App, Cursor, or even Anti-Gravity. So for me, I've been staying pretty much within Codex CLI. I have a bunch of skills that allow you to generate all of these assets integrated within your game so that they run perfectly. And just as a demonstration of how the skills work, I will be showing you how I created this crouch animation as well as this death animation step by step, the exact prompts, the exact workflows. And once again, my goal is to demonstrate how you can just use pure AI tools to build games from start to finish, doing everything from the coding, the art, the music, the sound, because I believe that with the power of AI tools today, anybody can be a game developer. Now, if you've been watching my videos, you will know that this has been a long time coming. The AI game development vibe coding resource pack is now here and available at vibegamedev.com. And here's exactly what you get. All of the latest drops related to the projects that I've been working on as part of this channel. And this includes all of the agent skills that you've been seeing me work on for the past couple of videos. And not only that, you get all of these source code, agent skills, resources for the other projects that I've been working on this channel. So for example, the game that you're looking at right now for today's video, I'm going to take this from zero to shipped all the way, and I'll be including all of the plans, the prompts, the resources, the skills, and the entire source code so that you can follow along with this journey. You'll be able to use these projects as a starting template, as a reference, or remix in any way that you wish. These resources have been extremely useful for people already on their journey to vibe coding games using AI. And to celebrate today's launch, early buyers will get $50 off the regular price. Link is in the description below. All right, so without further ado, let's get started with today's video. Let me just introduce you to the project. So I have two levels over here, and this is completely built using Phaser. And the main thing that we'll be focusing today is on how I actually created every single one of these animations here, whether it's idle, whether it's walk, whether it's for running, whether it's for crouching. This was all AI generated using a combination of image generation models. So no external tools. This one was just done using GPT Image 1.5 as well as Sora. Now, you probably can get away with using something else like Nano Banana or one of the Gemini models. In fact, I've already seen people already describe that they managed to get this working because the main focus here is not so much on the specific tools, but on the process and the agent skills that will allow you to create game-ready assets. Okay? All right, so let's just get started. I'm going to be using Codex, and I like to effectively stay within the CLI. In fact, what I tend to do is I'm now using something called CMux. It's like an application that's built on top of Ghosty. And this is generally how I do most of my development now. I'll be switching between CMux here as well as Visual Studio Code. Doesn't really matter which one you use. You can use any tool with these workflows, whether it's Claude Code, Codex App, Codex CLI, Cursor, or Anti-Gravity. So this video will be on your main character and how you go about generating all of the animations that you need for your main character. Okay, so the first thing you want to do whenever you've got like a dream game, like you've got a game in your mind, and this is the fun part, right? You want to brainstorm on what is the kind of game that you want to do. So here are a couple of mockups that I've generated. And these are actually the final 4 images that I got to when I was thinking about building this. So I think it's quite self-explanatory. So the game that I'm thinking about is a very simple game. But the goal here is that you want to be able to just run along platforms and then endlessly climbing all the way to the top. You might encounter some enemies that you see over here, and then you can pick up some coins. And that's just a rough idea. And the idea here is that start off with your mock-up of your game, right? Don't think about the character too much. Spend time and have fun. And let me just show you some of the ideas that I've went through. You can see all of these are the different versions of the game. Now you can see the problem. The art style was just not what I was looking for. This is just a little bit too high res. So I then asked it to improve it. And you can see here that I've saved every single one of my prompts that I've used as part of developing this game, as part of this repository. And the reason why I'm doing this is that I'm trying to document every single step, every single prompt, every single plan, so that I can distribute this and let people learn about how I got to this stage. It's very useful for me, especially when I look back and continue to improve my own workflows. And as I mentioned earlier, if you're interested in getting hold of the higher repository of this project that I'm working on, including all of the skills that I've been using, whether it's the Sora 2 skill, the GPT Image skill, the phaser skill, everything is all included here and is part of the newly launched game development resources over at bytegamedev.com. As you can see, I went through a bunch of iterations to get to the stage that I wanted to. So I would just continue to refine it, as you can see from the prompts here. And finally, I ended up with the 4 images that you see over here. And you can see it's starting to nail down on a consistent look, pixel art, and not too complicated, gold coins. And finally, I said, hey, you know what? I like this image over here. All right, so that's the first step. Just get a look and feel of what kind of game you want before you start thinking about how your main character is going to look. All right, so now that you've got your mock-up image, what you want to do is send this image and then ask your favorite AI tool to create a character. Based on where this character is in this mock-up, you want to start off with an idle frame, okay? So an idle frame, for those of you who do not know, is like when the character is at rest. This is the idle frame. So it's usually a bit of a breathing motion, and effectively, it's always the first thing that you want to do. So in order to do that first frame, let me just show you the results. This is actually the result of me just saying, all right, based on this image that you see over here, generate me an idle character. All right. And then you can see with our image generation model, the results aren't great, right? You really see the face. It got like the key aspects of it, like the red bandana and then the blue coat and the brown shoes and the brown trousers, but everything else, this is just not workable. And this is the reason why you want to be using an image generation model, whether it's Nano Banana Pro, Nano Banana 2. But in this case, I'm sticking within the OpenAI ecosystem. I have actually done several Nano Banana Pro image generation tests in the past. I post about it both on Twitter as well as in my videos. But for this video, I wanted to focus on staying within the OpenAI ecosystem. So GPT Image 1.5 is OpenAI's state-of-the-art and most recent model. Okay, so the way this works is that if I jump into my project over here, and I'm just going to slide this over to the side. So I'm going to reveal my folders, and you can see if I go into my skills folder, I have a GPT Image 1.5 skill that effectively is what I've been working on in order for me to create sprites for games using this model. Okay, and this is the key here where I train this skill both on looking at the APIs of Image 1.5 and also something called the prompt guide. So you can go ahead and just search for GPT Image 1.5 prompting guide and effectively just copy and paste this and ask your AI to study it because it gives you good guidelines. So this skill has already been trained on that. The issue is that the generated pirate is okay, but not great. So now I'm going to say, look at this image, it's terrible. And instead, what I'm going to do is say, use the GPT Image 1.5 skill. And you can do this within your Codex terminal. So I'll just show you here. You can say, use the GPT Image 1.5 skill. You can see it picked it up. And then before doing the full animation, focus on fixing this process. Generate the first frame of the idle animation, making sure you fix the pirate's discernible features. And what I also did was then I passed in this image over here so that this would know that this is my reference game that I'm trying to build. And so what this skill will do is that it will automatically take this very natural prompt that you have and it will create a tailored prompt to use Image 1.5. As you can see here, this is entirely generated and it's very specific and it gives you the best results, right? And this entire thing is done because the skill has already been trained. So you can see this prompt create a transparent first frame character, sell for a 2D side view pirate platformer, and then it has intended use subject, yada, yada, yada. And this says that it wants it to create it and then have it downscaled cleanly into a 64 by 64 frame, which is what I've already identified for my game to be like. So that ultimately I want this game to be fairly low poly or low pixel, 16-bit style, so that because I did static and I want to get this working on mobile phone devices as well. And you will see that GPT-5, basically what it does is that it created this high resolution image first, and then subsequently downscaled it into this version that you see over here. It's going to be able to look at an image, look at what you want. You want a character, you want the idle pose, you want the first frame, and then you want it in a certain style, and then it got it into this stage. All right, so I'm going to show you the You can see this was what was generated by image 1.5. And you can see this is the downscale image, and then there's a ShoreX version, so that it's easy to preview whenever you're in documentation. So this is the first step that you want to do. You always want to get the first frame of the character so that you have a somewhere to base. And this will be effectively your anchor. Okay, this will be your anchor, your reference image. And in fact, I'm going to write it down here, and I'm going to say anchor image, because this is the most important image that you're going to have, because you're going to be using this for pretty much everything else that comes along. So now we have our anchor image, as you see over here, right? So we're not using the high resolution one, we're using the low resolution 64 by 64 one. Okay, and now that we have this, we want to start doing some animation. So the first thing that I wanted to do is just create an idle animation, because it's the simplest animation that you can do. So the first thing to note is that there are different ways that you can think about creating the animation. You can use GPT Image 1.5 to create every single frame individually, but you will see that there's a problem, and you should never do this, okay? Because when you try to create all the frames of the idle animation individually, so you're basically doing 1, 2, 3, 4, 5 separate calls, the problem you get is the consistency. You can see that the pirate character doesn't really stay consistent, not even between the first and the last frame. In between, it loses the color, changes the height, and then like this one completely looks different. It doesn't really look like an idle animation. So what you can do is effectively, if your animation is fairly simple, you can just ask Python to generate the idle animation for you. This animation here was not done with any image generation model. This was effectively just Python using something called Pillow, or PIL, if you're familiar with Python, and it just moved the pixels around. And the end result is actually pretty good, right? It is a idle animation, but you can see it's not super complicated. It's just effectively moving the pixels up and down so that it looks like it's breathing, but it's not a very complicated animation, and it can work pretty well. So that's one way you can do it, and that's how I actually did the idle animation. But you will know that when it comes to more complex animations, this is not going to work. GPT 5.4, even with extra high reasoning or whatever, is not going to be able to generate complex animations for you. So how do you go about doing it? This is how you do it. The way that you go about doing it is we will be using GPT Image 1.5, but rather than doing every single frame individually, here's the trick, okay? The trick is that you take that anchor image that you had, okay? And then you blow it up into a large empty canvas. So I drew this outline around it so that you can see, all right? And the reason why you want to do this is that you want to not just submit this image, you want to submit this canvas so that the GPT Image 1.5 will know to fill in the rest of the animations for you, okay? And this will then be submitted into GPT Image 1.5. And then that's where you can easily then ask, I want an attack animation, or I want to have a hurt animation. And you can see the results are actually pretty good. All right. And let's just preview it in the game over here. All right. So I'm just going to loop this, and you can see the attack is also pretty good. And let's just jump into the game, and let's just show you here. I don't have a hurt animation, but I do have an attack. And you can see, there you go. The attack is there. Now you will notice a few things that haven't yet been fixed, but I'm going to highlight it for you. So you can get to a pretty good result just using Image 1.5 and using this technique, right? Now, the problem with doing it this way, however, is that number one, when Image 1.5 returns to the output, these images are oftentimes not ready to be implemented into the game yet. And there are two reasons why. Let me just show you what happens, all right? So now the first thing that you need to recognize is that these images are not normalized. The distance between each frame over here needs to be equal, right? When you're working with sprite sheets, all of these need to be equal, because otherwise it's not going to be able to render it correctly on screen. And you can immediately see that if you try to make this equal, this is not going to work. Sticking out and then it's cutting across, and you need enough buffer within each of the animations in order to make sure that it works, okay? So same thing for the HUD over here, but you can see it is, in this case, it managed to get it pretty far, but it's still not quite equal. Okay, so the step that you now need to do is what I like to call normalization. And normalization serves two purposes, but like the main thing that it does is that it tries to, first of all, make sure that there's an equal distance in the animation frame. And you can see this is very rough, but you can see this is a lot more accurate now, right? That's the equal distance. Now, the second thing that you need to do is that it needs to then do something smart, because if your animation involves changes to the height of the character, as you can see over here, if it tries to just maintain the height across, you're going to get this really odd behavior. So it needs to also know how to smartly detect the height of the main character and know whenever there's something from a weapon that's going up or something from a weapon that's going to the left and right. Okay, so this is the key thing that the game asset skill does. And this is a skill that is also included as part of the Vibe Game Dev resources. But the main thing to highlight here is that you can see that I've been working on this game dev asset skill for quite a long time now. It does everything from tile maps to doing with parallax, dealing with normalization. And this skill is pretty robust. And what it does is that it's able to smartly calculate the median distance or the median height of the character and to perform these kind of normalization steps. All right, so let's just show you the spreadsheet here. Okay, so can you see? All right, so this is what has come up. All right, and like I said, it's not normalized. And then finally, after it's gone through the normalization, it's then able to effectively put these animations into with the right space around them. You can see there is sufficient space, and for this third one, it correctly calculates the height of the character. So this is why this normalization step is very important, and you need that in order to achieve this outcome. But you can see here it's working well, and there's a few more tweaks that I could do, because you can see the character firstly loses a bit of character consistency. So I think I could use a tighter prompt. But the other thing is that there's a little bit of drifting as well, which can be very easily fixed. I actually fixed this in the walk animation, which I'm going to talk about right now. Okay, so this works as a very good way of getting the animations that you want. But I'm going to tell you that this is not going to work for one thing, which is walk and run animations. In fact, the number one complaint if you go on Twitter or on X that I get is that people say they tried to do this, not using these techniques or other techniques, but they just can't get the walk cycles looking right. They just mess up. And I'm going to show you what happens if you try to use Image 1.5. Look at this, right? These are different attempts that I took to use Image 1.5 to generate walk cycles. And I did everything. I did all different prompts. I did try to use a reference image. I tried to describe how the hands should move. And you can see it just isn't able to get it, right? Like in this case, it did the change in the hands, but the legs just never changed. And then they actually changed their character from a male character to a female character as well. And then this one, it just completely messed it up. And this last one, which was my last attempt, was the closest it got to, but even then, you can see it really struggles. And I'm going to show you how it looks like in game. I think I actually have a version. So let me just show you how walk looked like. It just doesn't look right at all. Look, this was the best attempt I think I got to retaining some level of consistency. It just never looks right. Okay. So how do you solve this problem? Well, thanks to a lot of people on X and Twitter as well, they suggested do not try to use an image model to create walk animations. Instead, you should use a video generation model. And I had really good success with that. Okay, so this is where Sora 2 comes in. Sora 2 is OpenAI's video generation model. They've also recently, I think a week ago, announced that they've enhanced Sora 2. So you can have longer videos, and they've improved the model as well. So this was actually done without the improvements. This walk animation, and then the ones that I'll show you later, when I do the crouch and death animations, those were done with the latest Sora 2 model. Now, the main thing that you want to note here is that when you're using a video generation model, it's a lot simpler. All you need is this anchor image again, and then all you have to do is just prompt it. So I passed in the prompting guide for Sora. So the same thing again, I just did Sora 2 prompting guide. Okay, and then I just copy and pasted this and passed it into the skill and trained it a little bit. And then I said, let's try to generate a walk cycle that will respect the style of the pixel art animations. The goal would be to then cut the frames on the video to then create a sprite sheet. And then this generated the prompt for me. Okay, so you can see here the prompt that the skill generates with the skill is here. And it does everything automatically such that it conforms to the best practices of Sora. And you can see that the end result is really good as well. And let me just show you the output. So you can see here, this is the result of using Sora 2 on the animation, and it looks so much better. Okay, it's not perfect, but it's so much better. It's getting the arms correct and the legs correct and they alternate correctly. And you need to remember to pass in the image reference, because if you don't use an image reference, which I did initially, now let me just show you the version I did. It doesn't respect the character consistency, which is the most important thing that you want to do. Okay, so then what you have to do is then it just uses the game asset skill once again, and together with the Sora 2 skill to then stitch this together and put this into a walk cycle animation. And you can see, I'm just swap it out here to the walk Sora. And here you go. It's a lot better, especially when you see it in-game. And in-game, you can hardly discern it. It feels the character is fairly consistent. It looks pretty good, at least for a first try. All right. And so I did the same thing for run. So you can see, all right, this is the run animation, exact same process. And I'm just going to show it to you here. So run, I just ran straight to Sora. I didn't even use image gen for this one. And you can see the run animation. Like I said, it's not fully perfect, but it gets you there. And there's a bunch of stuff that you can do to make it look better, because sometimes Sora tends to generate more frames than is needed, or it generates a much longer animation. This is where the game dev asset skill comes into place, because it's able to see whether a frame has been repeated and then squash it down. Okay, so that is the Sora 2 workflow, my friends. And effectively with these two models, like I said, you can get really far, and just focusing on the point of creating animated assets, especially character assets, you're going to be able to get really far just by using this workflow. As you can see, I've already generated quite a few different animations, and I've already put them all into the game. I hope this entire process that I've laid out has been clear and helpful to understand how you can go about doing this. And what I'm going to do now is I thought I'll show you step by step the exact workflow that I took to create the crouch animation that you see over here. I'm going to play here. All right, so you can see the death animation over here. There's a few more tricks to get these animations, but they pretty much was just me prompting the AI and then integrating it straight into the game. All right, so let's take a deeper look at the entire process. As you can see, I've got already a couple of animations here that work quite well. So I've got a jump, I've got the run, I've got the walk, I've got the attack. And let's go ahead and try to implement something else that's different. So I would love to have a crouch capability, so that if just say a projectile comes through, you want to avoid the enemy, you want to crouch. So what I'm going to do now is use the workflow that I have and showcase to you how you can go about creating new animations. So if I jump into my project over here, and I'm just going to reveal the folder, and there's this Codex folder, and in scales, you can see the GPT Image 1.5 and the Sora 2 skills. I'm also going to be using the phaser skill as well when we are implementing things. So these are the main skills that will be sufficient for you to effectively create new animations and then implement them within the game. Now, the main image that I want to show you that we have over here is the idle v2 image. So this is the main character. So this is kind of like what I call the anchor image. So everything goes based around this starting image. What I'm going to show you is that just starting from this image, I'm going to get this to effectively generate the crouch animation for me. Okay, so we're going to try two different methods. I'm going to show you the crouch using spritesheets, and then we will try to use Sora for a slightly different image, because why not? Because I want to show you how you can make use of either video generation or image generation to get to what you want. Okay, so let's just jump back. So you can see I have Codex over here. What I'm going to do is I'm going to switch my model to high. So in this case, I don't think you really need to go into planning mode, but because I'm recording this video, I really like to store all of my prompts and all of my plans so that as part of the resources that I've released, people can replicate it, and it's also a lot easier for me. So let's just get started. We'll switch into plan mode, go Shift Tab. All right, and then I'm going to say, I want to implement a crouch animation for my character. Okay, let us use the GPT Image 1.5 skill to create a spritesheet version of the crouch animation. And then we will use the Sora 2 skill to create a video version of the crouch animation. This will serve as our comparison. You will use the game dev asset skills to normalize the image, implement both versions of this crouch in the character test screen, and also in the main game, such that when I press and hold the down button, he animates and stays in the last frame of the crouch. So what I'm going to do now is that I'm going to kick this off, and then this will go into plan mode. All right, and so I'm going to leave this to run, and then we're going to draw back at the end to see what this ends up with and a showcase of what these workflows can do for you. So just want to highlight a few things as part of this run. Because I started off from a fresh context, you will see that it's managed to look at some of the asset generation skills and the instructions associated with that. It looked at how to use the GPT Image 1.5 skill as well as Sora, and then identified that there's already a pattern that's been used in this project. So that's all correct, and that's all part of how the Codex and GPT 5.4 analyzes the project before it starts making changes. And this is really the reason why going to plan mode is quite important, especially when you are starting off with fresh context. I could have easily resumed from, so if I had done Codex resume, for example, you can see that I actually have several other sections from default, and usually that would have the context from previously, which wouldn't need it to understand the whole code base. But in this case, I wanted to demonstrate how it would look like starting off from a new session of an existing project. So you can see in plan mode here, a couple of things have come up right now. So it says that how should the GPT versus Sora crouch comparison appear in the UI? And then it just says, I should just compare and test. All right, so the animation test shows GPT and Sora crouch side by side. Playable level uses one active crouch per variant selector. So what it's really asking about over here is that if you go to animation test, you can see that I have different versions of the animations. So let's just take a look. So you can see this walk that's by Sora is a lot nicer. And you can see this walk using Image 1.5 wasn't as good. So that's the reason why sometimes having comparison is good. So you can see this one is the jump using just Image 1.5. And then this is jump using Sora. Okay. And a lot of times this test scene is not sufficient for you to be able to draw conclusions. So therefore, if you go to the playable level, you will be able to see. So if I show you the jump for Sora over here, it actually looks pretty decent, even though when you looked at it in the test scene, it didn't really give you that sense. And then you can, if I swap over to the jump Image 1.5, that's how it looks. And you can see it's slightly different and it has a bit of a discoloration as well. So I decided to go with the Sora version. Okay, so that's what we're going to do, and that's what it's asking. I think it's saying that it wants to show GPT and Sora crouch side by side. I'm going to change this, all right? So both scenes and yeah, and I think I just want to do the selectors only version. The other way you can do is just press tab, and then you can actually explain what you want this to do. But I think we want to use the selectors only. All right, so I'm going to say use selectors only as how we have currently done it for jump and walk. The next question is what gameplay behavior should holding down use? Grounded only, horizontal movement stops, and then jump and attack are blocked. Crouch freezes on its final frame until release. I think that's what we want to do. Yeah. All right. So this is just confirming if you press down, whether you want the person to be able to continue crawling. And that's a good question. I think for now, I'm just going to do a static hold, and then we can see if we want to make the player actually be able to move in the future. Okay. So this is how I want to do it. I generally just want to be able to switch quite easily between the different versions. And we are still in debug testing at this stage, and the game's not fully in place right now just yet. But I think this just gives us a useful way to assess effectively how the different approaches and the different models, whether it's Image 1.5 or Sora, works. It's the easy way to compare between the two different models. Okay, so we're just going to let this run, and you can see it's come back with just a few more questions. Which crouch animation should I lock into the plan? Use the existing single animation preview pattern. Yep, that's right. And then add a dedicated touch crouch button. Okay, yeah, because I'm trying to make this a mobile game, and you can see this. So we're going to have a crouch button so that this will work on mobile as well. Okay. Ultimately, I'm going to probably change how this works. I'm still in the design phase for this game. And so I don't really know how I would like this to work with the whole premise of this game that I was planning to do, that I was working on, was to make this as simple to play as possible. So maybe we'll change the touch controls in the future. I'm not too fast. I just want to be able to debug it, make sure that it runs and looks good on mobile, and then we can assess the controls later. Okay. All right. So now that I've answered the questions and it has the plan, it's going to be able to go ahead and make an informed decision around how to go about implementing this. We'll just wait for this for a little while so that it can come up with the plan. I think it should have everything it needs. So you can see, as I mentioned earlier, we didn't need to explicitly tag the skills like this. It was able to identify all the skills just from the pros and the prompts that we gave to it. All right. So it's really intelligent. You don't have to worry too much, but sometimes you want to ensure, especially if you're using a voice-to-speech software like I was doing, you might want to be extra careful and make sure you tag the specific skill that you want to use. But for the most part, it should be able to get it right. All right. Okay. So it has asked another clarifying question. It says whether the video version means a raw Sora to clip shown to the app or the existing repo pattern where Sora generates motion source material and is then normalized. We want to do that. Okay. So we want to do a derived sprite sheet so that you don't embed a video, but rather it starts to cut out the frames from the generated video. So you can see this walk animation and this run animation. These were all generated from Sora videos. Okay, you can see these are all the frames that we have. All right, so if I just find a couple of MP4s over here. So we'll just say run Sora. So you can see this is a video. All right. And then after that, when it's decided that this looks good, and then what it does is that it will then export it. So you can see it then exports it into frame by frame animations so that it can be implemented in the game. You don't want to be embedding videos in your games at all. All right. That's not how games work. And you can see the proposed plan is coming up right now. Okay, so just very quickly, I usually just focus mainly on the summary. As long as the summary is got the main idea, that's usually all we need to do. And you can look at the implementation changes in more detail later. But honestly, just looking at the summary is usually the most important bit. So create 2 crouch variants, and then both variants will use animation key crouch, export to the right pixel size, and then it will keep the comparison selector base. Okay. So what I like to do, if you've seen my videos, I like to not implement straight away. I like to do the following, and I will usually say, let's just change the model down to medium, and I'm going to say the prompts, and then wait for my next instruction. And the reason why I like to do this is so that I have a running log of everything that I've done as part of utilizing Codex and working with AI. This makes it a lot easier when I'm trying to create these videos and share this material with people and my viewers so that they'll be able to replicate exactly what I was doing. It also makes it very easy when I want to prepare articles or behind the scenes videos or anything else that will allow me to make these things a lot easier. I'll just show you very quickly here, right? So if you look at my plans, you can see all of my plans are here. They're timestamped. And then I have all the plans that were generated by Codex over here. And then I have a prompts folder where I have every single prompt that I used, as well as any responses from AI. In this case, it's GPT 5.4. And then I save everything as much as I can. I like to have this in my project repository so that I can go back and look at what I did and summarize so that whenever I record these videos, I know exactly what I did. All right, so the prompts and the plans have now been saved, and I just want to take this chance to show you what I usually do. So I'm using, because I'm in this CMux Ghosty terminal, I have something called LazyGit, and the way that you do it is just run it for LazyGit, and you can see that I have the plans and the prompts that are saved over here. All right, and the reason why I like LazyGit is because I pretty much can just commit these changes without jumping in and out or having to run terminal commands. It's very similar to what you get inside Visual Studio, as you can see, but I really like to stay within the terminal most of the time. So what I used to do, I can just press spacebar to add all of these to stage both of these files, or I can just press A and it just stage all of them. Press C for commit, and I do feature, crouch, animation. All right, and then I'm going to say add prompts and plan. All right, and then that's pretty much that one done. And so now all we need to do is just go ahead and implement this plan. And you can take a look over here. You can see 58% is left. I'm going to swap this model to high so that it is going to take full advantage of its reasoning capabilities. And then one of the things that I want to ensure that it's going to do is that it's going to have to make sure that it implements the assets.json. Okay, so I'm going to say implement this plan using the right skills as required. Okay, and then I'm just going to kick this off and we'll just let this run. So once this is done, I will draw back and see what is it like. Ideally, we'll be in a position where we'll be able to check out the animations within this test scene that we have over here. And then we'll try it out in the playable level as well. All right, so now we are done, and I wanted to show you what the end result is, and then I'll talk a little bit about what I had to fix along the way. So I'm just jumping into this animation test scene over here. So first of all, these are the end results from both the image generation and then from Sora. So I'm going to show you the image generation one first. So this is the crouch, okay? And I'm just going to turn off loop so you can see that the character is correctly crouching in this instance, all right? And then let's just take a look at the Sora version. All right. And you can see this one is slightly different. So one thing that you will notice is if I switch between the image generation one as well as the Sora one, is that you will notice that Sora does a lot better at preserving the character consistency. And the second thing that I wanted to point out is I'm going to show you this version 3 of the crouch generation to show you what kind of problems you might face whenever you're using image generation for characters and how to fix it. Okay, so you can see in this case, this crouching animation is actually pretty good, right? But what is the problem is the character is just way too big, okay? And the reason why it's too big is because when the character crouches down, it still assumes, and just turn on the debug for a while, it assumes that either the width or the height is going to match what it would be when they are idle. And sometimes this is where something called normalization comes in. And another instance where this becomes an issue is, for example, when you're doing the attack. All right, so let me just show you this attack here. If you look at how the attack is, if the sword, when the sword is raised, the total height of the sprite now increases. But if you try to scale the frame for each image according to how the height is, you're going to get something bad. You're going to get something that's wrong. So you can see here, this was the generated images, and then we tried to put them frame by frame into a sprite sheet. Now the problem is that it tried to normalize the total height that you see over here of the generated frame and squash it to fit the height over here, which is not correct. What you want to do is you want to take the height of the character, make sure that it's consistent throughout the frames that you see over here, and then ensure that the sword peaks up above what the frame is. Okay, so this is really important. When it comes to normalization, this is the process in which you try to make all the frames within the sprite sheet correct and accurate. And there are different ways to do it. And this is one of the problems that I encountered earlier. And this is the way to solve it. Okay, all right. So this is the whole point of why I have this game dev assets.skill. This skill has been tuned specifically to deal with these kinds of issues whenever you have generated images. And this is going to happen quite a lot, right? Because you're going to have different kinds of animations for your characters in different poses. And it's quite important for it to understand how to normalize characters. So this is the process that I take to improve these skills over time as I've been working on this project. And the whole point of doing this is to provide you with the skills to be able to get to the end result as fast as possible without having to trip over these kind of things. Okay, so let me just show it to you again so you can see this crouch doesn't look right because it's not scaled correctly. And then when it's scaled correctly, this will look correct. This will look and form correct. This will form within the frame in an accurate way. So let me just show you how this looks like in the game now. So I can swap between the crouch animation. So I'm going to use the Sora version first. And so I'm just going to jump up here. Okay, and we can see that the character, I'm going to just crouch. And you can see this crouch is actually pretty good because it maintains the character consistency fairly well. And that's why I said with Sora, it tends to do really well with maintaining character consistency because you're providing just one image and then it's going to generate video based on the image. Now I'm going to swap it over to the image generation one. And you can see this one has a much lower crouch. So that's actually better. But the consistency is still not quite there. It just loses a bit of the accuracy of how the character looks. Overall, the end result is pretty good and it allows you to switch between them. Let me just show you what happens when you don't do the normalization correctly. So I'm just going to crouch right now. And you can see like it's crouching, but the entire frame is just too big. And this is the kind of result that you do not want. So what I've done was to apply the exact same process with the fixed scripts and the normalization to create a death animation for this player. So I'll just show it to you right now what the end result looks like. Okay, so if he touches this, you can see he collapses and he's dead and we need to restart this again. And the same thing, and this process was exactly the same. I just basically told the AI to say, I want to create a death animation, use both the Sora skill, as well as the GPT Image 1.5 skill to create it for me. And let me just show you here what the end result is. And like I said, I save all these prompts so that it's very easy to go back to see what I did. All right, so you can see this death comparison prompts. What I did say was that I said, let's now try to use image 1 as our base frame again. And just to remind you, this is the base image that I use for all of the characters. And then I basically said, let's just use image 1 as our base frame again. Use GPT Image 1.5 and Sora to create a death animation for comparison. Okay, and these are the two results. I'm just going to switch between them here. So this is a Sora one. That's pretty good. All right, I'm just going to turn off loop for a while so you can see he collapses. And then this is the image. This is the image 1.5 one. Now you can see that the scale is still a little bit off and I can fix this very easily, but I just wanted to demonstrate to you what was slightly different in this instance. In this case, I did something slightly different for the image generation model because what I did was that I actually have this purchase pack from LazyGit. You can get hold of this 2D pixel art character template asset pack. It gives you all the base animations that you'll be using for a platform. I was able to look at the sprite sheets and how it did the death animation over here. So what GPT 5.4 actually did was that say, hey, can I pass in this reference frame along with this animation and then use that to guide the death animation as well. And this was pretty much the end result as you can see over here. Okay, this is the end result of what you managed to do. You managed to take this pose as much as possible and then use that as a reference to apply the image generation. So I'm going to just pop this over here All right, and this one on the right is actually what came up from Sora. And in this case, we did not pass in any reference def motion. Instead, all it did was to just pass in this simple image and then describe. So you don't need to pass in any motion guide as we did for the image generation one. This one was solely done with text descriptions. So let's just jump into the prompts that we use here. Okay. All right. And you can see this is the prompt that was used. Okay. It says use a frame extraction source for 2D side view pirate platformer. All right. And then it says beat 1, stand idle briefly. Beat 2, stagger and lose balance. Beat 3, drop lower into a knee bend collapse. And then beat 4, and then so on and so forth. And the end result was really good, if you recall, right? Like this is actually completely text-based with just a single image prompt. And it was able to result in this def animation that you see over here that works pretty well. So if I just jump back into the playable level, you can see if I jump, all right, and then here you go, the def animation is playing. All right, so hopefully this shows you how you can make use of these skills, stay within your AI harness of choice, whether it's Codex, Cursor, or Claude Code. And basically, you can pretty much just stay within this terminal and prompt your way to get all the assets integrated within your game. And that's the workflow that I've been working for this game. The idea here is that I want to be able to build the entire game from the Codex application or the Codex CLI and do all of the image generation, do all the art, the assets, and the sound, music without having to open up a separate app and then having to prompt that and then save the images in. All right, so hopefully this has been a useful demonstration of this workflow. I really hope you enjoyed today's video. If you found this useful, give it a like, hit that subscribe button, and don't forget to turn on notifications so that you'll always be the first to know when new content like this drops. And if you haven't seen my other video where I showed you how I built a Final Fantasy Tactics isometric game without writing a single line of code, just using AI, you want to check out this video over here. All right, so till next time, I'll see ya.